Folks, I wanna ask you something. Are you subscribed? From looking at the stats, 79% of the people who view my videos are not subscribed. Now, YouTube may unsubscribe even, so always check and make sure. Heck, I was unsubscribed from Leto's Law and didn't even think about it for 3 weeks. Sure enough, YouTube unsubscribed me, so please check your subscriptions. Like I said, only 79% of the people that watch this video are going to be subscribed. And where that really counts is if you ask me a question in the comments, which I love comments, love thumbs ups. I used to love beer, but can't have it anymore. Anyway, if you're not subscribed and have the notifications on, you'll never know that I responded to your question. And I do read every single one of them, and I respond to 99% of them. So please make sure you're subscribed and have the notifications turned on to all. That way, when I take the time to answer you, I'm not just spitting in the wind and wasting my time. Anyway, back to this thing. It's going to be pretty when I'm through. I hope you enjoy this video. Thanks for watching. Okay, folks, going to start back on this little project. We got the first side done, and as I'm moving around getting some of these things set up, I'm going to tell you and answer some of the questions we had in the comments. Now, I guess one of the biggest questions we had was, well, if you push this down real hard and push this down real hard to make them even, aren't you putting a bow into it? Well, it was already bowed, and I'm not pushing them down hard. That's the key to this. Planers are different. Planers let the force travel in this direction. The most important thing on this setup is this stop block down here. That's what keeps the pressure going. When I get to finish plating this, these things are just going to be finger tight. Just enough to keep it from lifting off the table. You know, you do a mill like that and you kick things around. See, look here. See how easy that was? That's just holding it with a fraction. Just a little bit. Quarter turn. There's not enough pressure to bend this. There's just enough to hold it. Now, it took me a while to figure this out. Mainly because there weren't very many people to teach me how to use a planer, and a lot of it was just figuring it out on my own. Oh, I've had some help and a lot of people that used to run planers to give me hints, but no, there's nothing like doing it yourself. So, this may not be the way some people do it. It may not even be the right way, but it's the way that I do it and get good results. You know, I've had people ask me to take, why don't you put this over here, use this head for this side and this head for that side. I have found that when I push against something, it's not as accurate. Remember, I'm trying and shooting for and achieving 1/1000th of an inch down this 4-foot length. That's tough. You'd pay a lot of money for that if you were having to have parts made like that. When this tool bit, and basically this is just like a lathe tool bit you grind, it is being forced into this metal and cutting the metal off as this table moves. If it was a rotary cutter, the pressures are much, much, much less. The lathes are much less because it's going so fast. This is going pretty slow and relying on brute force. So I can't push against this and cut this at the same time with the level of accuracy I need. Oh, I could rough plane it that way and it would be fine, but I like to do what I'm doing all the time. That way I don't make screwy mistakes, like leaving the gate open and letting Dawn in. Now, another question people ask me all the time is, why don't you mount a grinder head onto your planer and have the best of both worlds? And the answer is, I've planned on putting one on here for a long time. But the problem is with this table, well, let me think about that while I clean up this mess. My wife says I need to be more pithy, so that's why I'm trying to figure out how to tell you this in succinct words. Dawn just says I talk too much. For years, I had planned on putting a grinding spindle on this machine. Wouldn't be hard to do. In fact, I've even got a spindle over there that I could mount it right up to this and go to it. The problem is with grinding, you need to use coolant to keep the heat out of the chips or the workpiece, I guess. And you've got a lot of grit flying everywhere. Now I have grit flying here. Just look at my hands. This operation puts in the air. But this table has ways on it that are oil bathed constantly. It's pumped into some pockets on the ways down here beneath the table, and it gets collected in the troughs around the table. I haven't quite figured out an easy way to put a tray on the table and then hold down clamps or whatever I need to do to grind it and keep the water contained, the coolant contained. I'm not going to contaminate the oil in this table. It'd be a nightmare. This is my baby. I've got to take good care of it. Well, I'm back. Got to put this down on the bed so I can stand this up on its back edge. I use this thing for all of my straight edges usually. I don't do that many 4-footers, but I have a way to account for the shortness of this with another item. Anyway, this has studs in it, and then I have some adjusting screws here that line up, and I can tilt it back and forth against this like a fence on a table saw. But I need to line everything up to where this edge of the straight edge butts up against this stop block. So I find it's just sometimes easier to get everything ready and put it that way so you don't have to mess around. See if I can find some. Like that. And that. Did I mention these things are god-awful heavy? Really heavy. Put that up there so I don't drop it. One good thing about the Richard King straight edges is these ribs right here are pretty much parallel. They're not tapered. And so you can line up pretty well with them. There we go. And once I get one set up like that, I go ahead and move this over in line. Now, I need to get it kind of parallel with the table. So I use my handy dandy homemade gauge to check it out. I think this was just some scrap I had that I threw together because I needed it quickly. That's good. That's a little bit more now. Now we've got it roughly aligned. It doesn't matter if I've got it perfectly parallel with the table in this operation because I'm just planing this surface. I use another part that I need to go get. A big angle. And I put it down here to support this area because this is where the maximum force is. You don't even see me. I put it down here, and I also put a smaller one down there because on a planer, it's brute force. The blade shears the metal off, and when it hits this edge, it pushes everything that way. And this thing's so strong, it'll throw it through the wall. So you have to secure it in the direction of force, but let it loose so you don't bow it. It's a fine balance. So by clamping up here, I keep this from moving, especially right now when I'm doing a lot of the rough planing. I'm not being especially careful. I'm just getting the metal out of the way. So that right there helps a lot. Now, if I had a bigger piece of this stuff, it would be okay. In fact, it'd be better, but it costs money. And down here, we'll use this one. One of the tricks I use is putting a stud up here and then clamping both of these pieces at one time. It's easy on the setup. Another one of them. I use a lot of washers like this that I've cut off in the half so I can get it up closer to things if I need to. Works well. So now with two simple hold down clamps, I've set up this whole fixture. This I tighten down because I'm tightening the fixture down, not this. I don't know what's up with that little camera. Now, I can tell that this angle is just a little bitty bit off. I'm going to tighten these up and see if that corrects it. And if it does, then I'll shim up here. See what that does. Longer one there. I don't like using it for that because this will stick out and could grab you. I doubt if it would. So we'll just go and use one of these. Now this I can tighten up because I'm not putting a bow into this surface. When I get through, everything will be relaxed on the finished planing. That right there is perfect. Now up there is pretty close to perfect. And remember, I'm just rough planing it now. When I go to the final planing, I can dial these two surfaces in perfect. When this tool bit hits this surface, it digs in and it tries to lift this up off the table. It pushes it this way and lifts. So I always put a hold down clamp down here on the bottom of the table to this area right here, and that prevents it from lifting. I sometimes get pretty aggressive when I'm doing this part, so we don't need any lifting. Get this semi-level here. This doesn't matter so much if it's tightened down until we get to leveling this out some. So we're okay in that dimension. That looks good. We're tight up against that. We need to check to see what this surface is doing now. And my little surface gauge comes into play here. Now these are handy for doing this kind of work. I know you see them all over on the Pakistani channel. They use a bent rod or welding rod or something. It'd kill for tools like this. We're really lucky to live where we do. Let's get it on up. And remember, we're just comparing things right now. We're not measuring so much as we're comparing. That's pretty even all across the surface down here. Remember, this is a casting. Really close, actually. In fact, it's touching right there. And you get down here, it's 1/8 of an inch or more. So I've used my gauge and determined that I don't need to shim this to get close here. It's close enough. Less than 30 seconds. And this is a casting. And it's probably bowed pretty good. So this end here and this end are within 1/32 of an inch. This end here is down at least 1/8, maybe 1/4. So we've tightened it down so it can't lift this way using this clamp. We've tightened it to this so it can't lean back and forth, and we've got to put some C-clamps here to finish that project off. And we put a stop block to keep it from going that way. We're nearly through. So we're going to clean off the table and do one more operation before we start planing. That operation is to put a chamfer right here. You got to have a chamfer. Cast iron tears out when that bit hits the surface, and it's nice to have a little ramp in there so it kind of eases into it a little bit, not just a wall. Down here on this end, we need another chamfer because as this force is going, it will split the top edge off. It just fractures it and goes on off. But if you put a chamfer on that end, it won't do that. Best tool for a chamfer, a grinder. Okay, my second problem is if I was to start this up right now, this would crash into this arm and this would go flying that way. So I need to raise this up to where the tool bit is at this level. I got to go up about 6 or 8 degrees, or excuse me, 6 or 8 inches. Now I look at my indicator that I put on this head here, and I'm right in the middle of travel, which is a good place to be. So I now have to unlock and unclamp the arm from the column. And on this side, I leave this wrench there to remind me that it's locked. In a minute I'll show you why I do that. But there's 6 bolts down through here that are locked, clamping that edge. And when I move it, I will then tighten them all back up. Okay, put my wrench back there to remind me. Come on, you guys can go with me. Don't know if I've ever shown you back in here. That's all the controls at the top of the head for lifting the arm. This is all the electrical controls back here. By order of war production. I should take this tape off sometime. The back here is where the back clamps are. These 2 clamps here clamp it down. So now the arm is totally unlocked. We can go around here. Same thing to me. And now we can use one of the 4 buttons on this machine to raise this head. By pushing this in there and then using this. You can get real close. Need to go up a little more. Remember I told you that someone I forgot to unlock it one time. Up there, they did a really nice job of welding that back on. I don't want to do that again. I didn't do it in the first place. If I did, it was Don's fault. Okay, now I'll get the bolts back. Now, I want the machine to warm up. Get all the table lubed and running back and forth nice and easy. The hydraulics fill up all the lines where there may be a little air bleed or something. So I'm going to move this over here out of the way, start the table up, let it warm up, and then we'll start milling it. Okay, now that I've got the machine warmed up, I'm going to set this tool to where I skim the surface of this. And what I'm doing is I'm looking for any major hills or bumps, or I know that this end and that end are going to be higher than the middle. So I need to be very careful in getting this tool to a height that is not taking too much material. And then I need to be careful that there's not a big hill out here in the middle that the tool hits and triples the depth of cut. So I want to skim over this whole thing to make sure that I'll never take too much of a cut as I go across, because that's what causes accidents like on that table. But Don stole my handle, is staring me in the face. Sorry, Don. Now, one thing that I was worried about and I needed to check was this bit touching this surface is about a 32nd underneath. It's not touching yet. Whereas down there, it's touching all the way across. So I went and got a caliper and I measured the thickness of the casting in that area, because I don't want it to be thin on one end and thick on the other, taper. And sure enough, it's about a 32nd of an inch thicker down here. So I'm okay. I don't need to shim it out anymore to make it equal. Another thing I want to talk to you about is the surface of this. Now, I don't know who cast this. I don't know which foundry Richard used. And I don't know how they heat treated it and to what quality that heat treat was. So as you noticed, I couldn't get it into my oven, so that's why I'm doing this first. But I do notice that I know it's been heat treated because I'm looking at this surface. This surface is hard. And I've encountered hard surfaces before when I was first learning to heat treat. And I found that until I came down to 10,050 degrees for my temperature, I was cooking the outside edge of this and making it harder and harder. And so this is a very hard surface. Once you get past this, the cast iron's a pleasure to plane. It just peels off of there. It's so nice. It's like leaded steel, you know. The difference is that dramatic. I know this sucker's been treated above 115 degrees, or excuse me, 10,050 degrees, just because it's so hard. So the tough part of this job is getting underneath that and getting out of there. And because it's so rough and wavy, I can't get underneath it like you could like on a lathe where, you know, you could get real deep. So bear with me. This is the rough part of the job. Now it's taken 63 thousandths from that beginning. And remember, this is a really expensive casting. I can't get rough with it. I'll break it. So I take my time and do what I can. It's like you work with the wood, you know, the grain and everything. So that's what I'm doing here without being too rough. hard. This thing's hitting this and ramping up and skating on that hard layer. So what I'm going to do is, see, it's only hitting here. And it's hit a few spots in here. But I'm going to try to get off to the side and use the side of that cutter to get down underneath that layer even more. This is what I wanted to show you. From our 0 point, I'm now 95 thousandths down from that 0 point, and I've gotten underneath it here. But once I get out here into the middle, it's still skating up. But then it's getting down here to the thicker part of the casting. So what I'm going to do is I'm going to try to get under this whole dadgum layer. It's so hard, it's just picking up my head, skating on it. So we're going to try that. If I go another 25 thousandths, maybe I'll get under it all. Bear in mind, I could set this thing up and take a ½ inch off this thing, but I'll wreck that webbing. Just trying to be careful. We're now at 118,000 off of 0. Okay, I'm really underneath it there. I'm hitting it in here. But see that white stuff right there? That's a hard spot. That's where the metal chilled when it was cast. And it's 10 times harder than this side is. Now also, as I come on down here, if you notice, I'm losing my bevel. And I'm going to start chipping out this edge. So I need to put a bigger bevel on that. This end, I'm going to need another one, but not right now. I'm going to drop it down a little more, see if I can get below that hard spot. Just have to take more time going across. I'm now at 130 below the 0 point. Have to grind that hard spot off if I can't get below it. This is what I'm doing to change, turns that screw, which turns that saddle. And that's the same thing as if I had to push this lever into automatic, and it would do that automatically. But because of that depth of cut, I don't want to do that just now. Something semi-interesting for you. As you see, we like about 3/4 of an inch getting over there to the edge. Get some of this bad stuff out of the way. And you can see this edge right here. Even though this is the same thickness here and here, this was thicker when it started. And so this is the depth of the cut here compared to the depth of the cut over here. And when I first started touching it, I was at, I'm 130 thousandths down now. But now you can see I've got a bad edge right here. I have to get below it. But I'm starting to run out of the casting here. It's rubbing. It's getting in that hard spot. See the silver right there? And so we're going to finish going all the way over. And then we're probably going to have to take about 30 thousandths to get that out. Maybe a little more. But what I look for, and what scares the dickens out of me all the time, is inclusions in castings. I found them in everything. You get in there and all of a sudden there's a void. See, like these little 2 points right there? I think those are just from the surface. But I swear to you, I found sheetrock screws in here not melted. I figure they put it in the casting to increase the property of the cast iron, but sure sucks when it doesn't melt. It's got a big void. So hopefully we won't find any of these. Let's continue on. We'll go ahead and get all the way out here. And I would stop right here. But I need to get this heavier part right here off of here. Once I get that off, the cuts will be more or less even, except for in this area. Chamfer's still good. I'll need to touch that up. We'll do it right now. All right. Got it down to where most of the hard stuff's off. As you can see, we've gone all the way across now. This is going to have to get down below that to make it look nice. Now, if I get closer, I could just bevel this edge, and that'll be okay, because remember, you're going to take more off when you're scraping. But I'd rather get rid of that right now. And because I have to get all of this out. See how it's all low right in here? Now, tear out is common because we're on that edge of that angle. This angle has to come from out here and go down below that nub and come up into here. So we'll be taking off quite a bit, and when we do this side, it'll make that edge straight. So as you can see, I've refreshed this twice, and I just need to be careful. I don't see anything major going on. My poor bit's getting pretty messed up, so I don't know what it is with that camera. My bit's getting kind of rugged, so I'm going to just touch it up real quick, and then we're going to take about 30 or 40 thousandths off of this to get it all down to nice cast iron. And we'll see what's happening then. I hate doing this because now I got to go through the sets of getting it all straightened back up. I don't know if you can see this or not, but this is the cutting edge right there, and come on, camera. See how it's wore down the bottom of that cutting edge right there, made a little flat on it. We'll get that taken care of. I've gotten down below the wear layer, the hard layer, I'm going to let it go into automatic. And that's this valve, that's this handle here. You need to take this handle off because it throws it off on the ground. That's that TIG weld. I've welded that thing up 12 times before I learned my lesson. Wait till it comes okay. Turn this in the direction you want it to travel. Holding it in place. See how far it's going to turn over. Doing about a 1/4 inch step over. Hopefully that'll get it down below my layer. Project, you can step away now and let it roll. Kind of hypnotizing. Visitors to my shop just kind of sit here watching this and get hypnotized. I could even make Dawn quack like a duck if I want to. Not that I would ever do that. No. Okay, maybe once or twice. Still have the bird spikes up so he can't lean on it. When we get out close to the end, I'm going to take it out automatic. And I'm going to do the last little bit smaller steps. Don't want to take a chance of knocking the edge off of that corner there. Okay, I'm going to take it out of manual or automatic. I'm going to give it a little bit of cut over the next time. Spring pass there. About 1/8 of an inch. That's an unsupported edge out there, basically. We're getting to the end of that 45-degree angle. Knocked off that. First time that one's ever fallen off. You can see the difference in texture from where I was hand stamping it and not taking a bigger, deeper cut than where I was doing this. So just to get rid of the rest of that little hard spot, I'm going to put it in automatic and take 5/1000ths of it off going across. Remember how I said sometimes there's imperfections in the castings? That's where that edge was. It's a little deeper in there. Just have to see what happens when we get in there. Now this is a very sharp edge, and this is a very sharp edge because it's that 45-degree angle. So I'm going to file it up. But this is as far as we're going to go for this planing. I'll be right back and tell you about it.